Hey guys, this is Module 4, Lesson 5. I wanted you to look at this purple circle, and I've laid my right angle templates on here. How many right angle templates fit in this circle? I hope you said 4. 1, 2, 3, 4. And if you remember, every right angle template has a specific measurement because right angles measure exactly what? 90 degrees. That's right. So this is 1/4 of the circle because it's one of 4 parts. What if I take away 2 of the 4 parts? How much of the circle is uncovered? Hopefully you said 2/4. And then if I take away the third one, how much is uncovered? 1/4, 2/4, 3/4 is uncovered. And then if I take away the last one, that would be 4/4. Anytime I have a number over itself, that's one whole. So I had 1/4, 2/4, 3/4, 4/4 of the circle. I want us to think about the turns that we made. So I'm going to put a circle here underneath. And so if I turn it 1/4 turn, let's see if I can get this to work. That's 1/4 of the circle. That's 1/4 turn. One right angle template. I turn it halfway, that would be 2 right angle templates, and 2 right angle templates would be 90 plus 90. And you know a straight angle equals 180 degrees. So this is 180 degrees. So up to here would be 90 degrees. To here is 180 degrees. And if I turn it again, 1/4 of a turn each time, now I'm at 3/4. So I have 90, 180, 270. So 1/4 turn is 90 degrees. A half turn, or 2/4 turn, is 180 degrees. 3/4 turn is 270 degrees because that's 3 90-degree angles, and 3 times 90 is 270. And if I turn it 4/4, I have turned it 360 degrees. There are 360 degrees in a circle. Now we're going to take a moment to look at a protractor. I'm going to put this here. I want you to kind of analyze that. Let me see if I can zoom in just a little bit. So kind of look at that. What do you notice? Hopefully you notice here's a 0, and it counts by tens to here to 90, and then it counts backwards to 0. And then it goes from 0 to 90, and then from 90 to 0. But if we look at the outer rim, we notice over here we have 360, which is a whole circle, and 0. So if I start here as 0, 10, 20, 30, it counts by tens all the way around the circle till it comes back to 360, because there's 360 degrees in a circle. So 1 degree equals 1/360th, because it's 1 of 360 degrees. And here's the word degree, so you can see that. We use a protractor to measure angles. So let's look at our circular protractor and notice our right angles. So that's 90. Oh, let's start at 0 here. 0 to here is 90. 180. 270. And this gets us back to 360 right there. Okay, now we're going to look at some smaller angles. These are 45 degrees. So what I've done is I've broken each right angle template in half. And so I start at 0, I have 45, and there's my 90, and then 90 plus 45 is 135. 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 45 would be 270. 270 plus 45 is 315. And 315 plus 45 gets us to our 360. So this is the angles if I broke them in half. Those are the measurements. You will need that for your problem set. So we're measuring this part when we say this measurement. And when I say I'm going from here to here, 0 to here is 135 degrees. So that's an obtuse angle. You need to remember acute angles are less than 90. Obtuse angles are greater than 90. So on your problem set, you'll use this for set A, that you will list these angles. So you might want to pause the video to do that. That's set A. Set B, we are breaking it into thirds. We're breaking the 90 degrees into thirds. So a third of 90 is 30, and then 60, and then 90, plus 30. Each time we're adding 30. 120, 150, 180, 210, 240, 270, 300, 330, and back to 360. This is set B. You will need those measurements for number 1, set B, on your problem set. So you might want to pause the video to do that. And then you will answer the questions where it says circle any angle measure that appears on both lists. So up on 1A and B, circle any of the angles that are the same in A and B. And then what do you notice about them? What do you notice about the ones that are matching? And then number 3, it says to look at problem 1 and name all the angles that are listed that are acute angles. Remember, what is an acute angle? What is its measurement? Look in your notes. And number 4, list the angle measurements from problem 1 that are obtuse. So look up at number 1 and any measurements that are obtuse angles. Remember what obtuse is. It's greater than a right, but less than a straight. And then on number 5, it says we found out today that 1 degree equals 1/360th of a whole turn. It is 1 out of 360 degrees. That means 2 degrees would be 2 out of 360 60ths of a turn. So what fraction of a whole number is each of the benchmark angles you listed in problem 1? So you have to go back to problem 1, and in set A, let's think about it. If in set A we wrote our first degree was 45 degrees, so that'd be 45 out of 360ths. And then you need to list the rest of the fractions for set A, and then you need to do the same thing for set B. And set B, the first fraction not fraction, but degrees was 30, so the fraction is 30 out of 360. And you need to list all the rest of the fractions and put a little comma in between. And then it asks you to think back to our circle that we had how many 45-degree angles did it take to make a whole turn, to go from here to here? How many 45 degrees did we have? You might pause it and count. And then for 7, how many 30-degree angles does it take to make a full turn? So we went from here all the way around. How many 30 degrees did it take to make a full turn? And number 8 says if you didn't have a protractor, how could you construct a quarter of it from 0 to 90 degrees? So think about that and see if you could think of a way that if you didn't have a protractor, how you could construct a quarter of it. That's 1/4 of a fraction from 0 to 90 degrees. All right, good luck. Bye.